and welcome to the 8th webinar of the DevConnect Research Network's webinar series. We are pleased to host two presentations today. They are covering very important issues at the intersection of health, climate change, development, and gender. So the first presentation, entitled Natural Resources and Gender Inequality in Education in Africa, will be delivered by Idrissa Ouedraogo from Thomas Sankara University in Burkina Faso. The second will be, it's entitled The Womb Under Heat, Temperature Shocks, Maternal Care and Birth Weight in India, will be presented by Sapan Pradhan from Jawaharlal University, Nehru University in India. Sorry for the pronunciation. So please join me in warmly welcoming Idrissa and Sapan. Thank you for having agreed to present your papers in our webinar. I would also express our gratitude as DevConnect co-founders to our discussants present with us here. We have among us Yasmine Abdelfattah from the University of Prince Edward Island in Egypt, Susanta Datta from RK College of Arts, Science and Commerce in India, and Pham from Paris Nanterre University in France. Thank you for your contributions and for your time and effort. We will begin with Idrissa's presentation. I would like just to mention that each presentation will last for almost 20 minutes, followed by a discussion of 10 minutes, 3 minutes per discussant. And then we will open the floor for a Q&A session of 5 minutes so that we can also allow the presenters to give their response, to respond to the comments and suggestions. So please stick to the time so that we can have a smooth and engaging session for all participants. And with that, let us begin with the first presentation. Idrissa, the floor is yours. Thank you. So can you share your screen, Idrissa? Thank you.
Yeah. So thank you for the floor. Let me share it. Can you see my presentation?
Yes, we can. Thank you.
Okay, thank you very much. So please allow me to thank DevConnect team for the opportunity they give me to present my paper on natural resources and gender inequality in education in Africa. So I will start with the background. Gender equality in education has been linked to a variety of favorable outcomes for women, for their family, and for the society as a whole. Empirical literature show that gender equality in education foster women economic and political empowerment, reduces incidence of early marriage and also of fertility rates and child mortality, and also improve the family well-being. And overall, it ultimately foster economic growth. So it's therefore important for us to understand the drivers of gender educational inequality in Africa. So Africa remains the regions with the largest gender gap in education and also persistent gaps. At the same time, many African countries are rich in natural resources, and there is debates in the literature on the effect of natural resources on many development outcomes in Africa. So in this study, we hypothesize that resource-rich countries may experience a gender resource scarce, particularly in the education sector. So natural resources may undermine gender inequality in education through the gender resource scarce and death disease mechanism. But in the empirical literature, there is little evidence on how natural resources affects gender education equality in education in Africa. So so natural resource can affect female education investment through the research curves, thesis, and increase gender inequality in Africa. Extractive sectors like the natural resource sectors often favor male employment because they are male-dominated sectors, and then they can reduce incentives to invest in girls' education through the labor markets. And resource rents accruing to men employed in extractive sectors produce an income effect that affects the marriage markets and leads to higher fertility rates and therefore lower education among female. So through the extractive institutions, Asemoglu and Robinson, it creates enhancing activities, conflict, and reinforce also patriarchal norms, which can reduce investment in women, including their education. So resource can be a curse for African countries, particularly in the education sector, and access to equitable access to education. Our second hypothesis is that using revenues from resource sector to invest in education can moderate or even offset this negative effect. So our study covered 52 African countries over the period of 2000 to 2022. The outcome variables are the gender parity index at all levels of education, as primary, secondary, and tertiary. The independent variable of interest is the natural resource rent in percentage of GDP. And the control variable that we use education expenditure in percentage of GDP, GDP growth, and women political empowerment. We use OLS with fixed effects, time and counter fixed effects. We also use two-stage least square as our main estimator, and further use the limited information maximum likelihoods and instrumental counter regressions for robustness check. So income from natural resources are our main interest variable, and we use as instruments. We use the commodity net export price index, which is the individual commodities weighted by the ratio of net export to total commodity trade, which is from the IMF databases. So, preliminary results show that there is a negative association between natural resource rents and gender equality in education. So we see that from primary to tertiary education, we see that this negative trend. When we split the sample into two groups, first one group which has low level of education spending, and other group which has higher level of education spending, we see that countries which have higher level of education spending, we see that the trend is less negative than those where education spending are lower. So, and we see this trend both in primary and secondary and also the tertiary education. So what the econometric results shows is that natural resources tend to have negative effects on gender education equality in African countries. So our findings show that natural resource rent reduce gender educational equality, and that these negative effects or those negative effects increase with educational level. So the effect is more important in the secondary and tertiary than in primary education. So we can see that from the table. When we use the instrumental variable counter regression, the results show a stronger adverse effects in countries already characterized by large gender inequality. Okay, and meaning that resource rents reinforce pre-existing educational disadvantages for girls, and also that inequalities tend to feed on themselves. So our finding confirm those of Ross 28 to 28, which shows that oil-rich countries tend to have less female participation in public and economic life because of reinforced and entrenched patriarchal social norms. And also there is also empirical findings there's also empirical findings also in the literature in specific countries in Africa, which shows that there is a gender death disease curse in Africa. For example, in Nigeria, Salali Martin and Subramanian shows that the oil wine fall has not translated into equitable educational progress in this country. And in North Africa, in countries like Algeria, Morocco, and Tunisia, Ross alluded to similar effects. In Tanzania, there is also a finding for a research from which shows that we also had similar effects in this country. And in Burkina Faso, where I live, I also see similar effects because with the gold booming in Burkina Faso, people tend to withdraw their children from school, and because children tend to leave schools and go to the goals, to this sector, and when they get income, they get married, and also girls are get out from the school, and so this increase the gender inequality at the educational level in particularly in Burkina Faso, where I can directly observe those facts. So the second part of my research that government education expenditure can play a significant role in this. Okay, when we interact natural resources with government education spending, we see that it moderates these effects. Okay, and it can even offset this negative effect of resource rents, at least from certain thresholds. Okay, so for example, in the primary at the primary level, governments will invest, according to our findings, at least 7.35% of GDP to offset the negative effects. From the secondary education, they should invest at least 8.35% of GDP in the education sector to offset these effects. From the tertiary level, we need more resources to offset these negative effects. So meaning that this will need significant efforts from different government, because when you see the average education spending in Africa is around 4.1%, which is very low, and even with this level, only 52%, yeah, let's say, of those countries don't even reach this level. So meaning that significant efforts should be done in this effect. So these findings confirm the ideas from Keynes, okay, that public spending play a fundamental role, in the distribution of resources, okay, meaning that public education spending mitigates the negative effects of natural resources on gender equality in education in African countries. And we see that when you plot those figures, we see that there's a negative effect which can be offset at certain thresholds. So the one we have just indicated. So to conclude, natural resource rents are associated with lower gender equality in education across African countries, and increased public education spending can mitigate and potentially reverse this effect at certain threshold of investment in education. Okay, so in terms of policy implications, governments should use resource revenues to finance education, to, for example, scholarship and conditional transfers for girls, but like to reduce the direct cost of access to education, and also use gender sensitive budgeting, in this sense, and also increase use the resources, the income from these resources to increase the supply of education to, for example, school infrastructure or investment. And finally, we believe that economic diversification could also be a solution, because it can increase the labor market access for women, and therefore the return to education, and which will encourage parents to invest in their girls' education. So I don't know. Let me take the time. So I'm beginning the time.
No.
Thank you for your attention.
Thank you, Idrissa. You stick to the time, and the presentation was very clear and interesting. Very interesting paper that combines the natural resources to the educational disparities in Africa. I will leave the floor to the discussants. Let's start maybe with Yasmine, Abdelfattah.
Good afternoon, everybody. Thank you for the opportunity to discuss this paper. It's a very interesting paper. I went through the paper. I have a couple of comments. I need to figure out the transition mechanism. So the first hypothesis state that natural rent affect inequality. So what is the mechanism from the natural rent to the inequality? This should be discussed in the paper. Each hypothesis under this should be explained how this is from this point to that point. That's one thing. So when the discussion is talking about the transition, I feel like there should be a storyline that is why Africa is different from the other continents. Is there other countries, they behave different than the African countries, and how this is compared to the rest of the world. So that's one thing. The second thing, I felt like there should be a lot of recent citations that should be added, and some of the literature needs citation as well. So this one thing. When it comes to the theoretical model, I felt like there should be explained what is the macro model used and how it's related to the theory. So, for example, is it under the new classical growth theory? Is it under the Cobb-Douglas? Is it human capital theory? So this should be highlighted. Also, the value added of the paper. This should be illustrated more. For the econometric model, I feel like adding the governance indicators, rule of law, would add more to the model. And sometimes these indicators, they are endogenous, so there should be taken into consideration the endogeneity thing. Again, for the econometric technique, I would suggest heterogeneous analysis, because not all Africa looks the same. West Africa different, most probably different from East Africa, North, South Africa. There are differences between these countries, and the different types of resources rent. So not all the country, they have the same kind of resources rent. For suggestions for the type of econometric model that can be used, local projections, moderate diff and diff. So these are the things that I would say about the paper. But the paper is interesting. It needs a little bit of like refining and looking at what is the most recent econometric technique that is in the literature to make it be able to be sold to the journals, international journals. Thank you.
Thank you, Yasmine, for the insightful contribution. It's really interesting to hear those remarks and suggestions from different discussants. I hope that also Susanta will be able to add to your remarks to be able to help improve the paper of Idrissa. Go ahead, please, Susanta.
Yeah. Whether my screen is visible, please confirm.
I prefer that, yeah, maybe we stop sharing the screen. You just give your remarks, Susanta, without.
Is it visible now?
We prefer not to share your screen. Maybe you can just share with us your remarks without sharing the screen.
Okay, sure. So first of all, the paper raises an important question whether natural resources wealth weakens gender equality in education across African countries, and whether also public education spending can moderate that effect. So the question well motivated, and definitely it also raised the old theory proposed by Ross that educational opportunity between and its distribution among boys and girls. Now coming to the empirical design, first of all, it's 22 years time horizon across 52 African countries. Now the thing is that it is not very clear from us across the grouping, so clustering and grouping of the countries, because this is a country level study. So broadly, we will have the aggregate level or average level of picture. But even if we consider a particular country and within, and if you conduct the same study at the district level, you may find another type of findings. So my point is that although that's a good attempt, but categorizing or stratifying the sample of countries and then looking the same question, looking the same angle across different groups, that may give more insight. The author used different technique well as, but it has not clear whether the heteroscedasticity, because WLS is one of the important techniques for that, because if there exists heteroscedasticity, we cannot use OLS. So that is not clear from the paper, but that part should be taken care of. The previous discussant has already talked about endogeneity part, so I am not discussing much on that. What is important based on my understanding is that one thing, if we look at the results are consistent across the specification, but at the same time, the inference would be more convincing. If the paper discuss heteroscedasticity, serial correlation, because time dimension is one of the important aspect here, and cross-sectional dependency. Now, the cluster level dependency is one of the important things, because in terms of education, in terms of government policy, there might be the similarity in terms of tradition also. So some sort of a diagnostic test to check cluster dependency or cross-sectional dependency, that may be one of the value addition. Now, the most important identification concern is exclusion restriction. Because the paper relies on the commodity price instrument, it would be useful to explain more clearly why the instrument affects gender parity only through resources rent and not for any other macroeconomic channels such as income, social conflict, or fiscal capacity, because different countries, they are having different fiscal capacity. Not only that, under Green Climate Fund, Africa is getting huge fund for energy transition and all these things. So such thing should be taken care, I hope. And another point is concern in IV work and recent methodological discussion emphasis that exclusion restriction are often the weakest part of the otherwise strong design. So a brief stationary discussion would be helpful if any series display persistent trend. So although the more immediate concern here is error dependence rather than the pure non-stationary. So substantively, the findings are perspective. The paper shows the natural resource rent reduce gender parity in education, but that is a very broader statement which I understand, and that the negative effect become stronger at higher level of schooling. But what I believe, if you change the unit of analysis at the district level or block level, we can get a slightly different results. Next is moderating role of public education spending officially useful because it's point a clear policy response. Overall, this is a strong paper that had resource cost literature by showing the cuts may operate through gender inequality in education and the public policy can partly offset that. However, it has shown that around 50% of GDP is responsible across 3 sectors, and that's a quite a huge number. Thank you very much.
Thank you, Susanta. I will move forward to Kim, and then we'll let you, Idrissa, try to give some elements of answers to the discussants. Please, Kim, go ahead.
Thank you so much. So I will keep 3 minutes. I will try to keep 3 minutes. So thanks so much, Dr. Ouedraogo, for your presentation. So quickly, the paper is very well written and it's easy to follow. And I think it's a very policy relevant question you are raising. The empirical analysis is ambitious and the policy implications are following me potentially important. So I have just a few comments regarding the presentation of the paper before asking some questions. The first one, I feel that the introduction is rather long. I believe that if you present the literature review in a separate session, it could improve the readability of the paper. The second comment regarding the difference between the theoretical model and the empirical specification. I find that they are very similar. So I think it's not really a good point to present the theoretical modeling in this way because the added value is not really clear. The third comment regarding the presentation of 3 hypotheses, I think that you could present in a separate paragraph or a kind of separate position. And regarding table 1, I think you should present the sample. I mean, the same number of observations for all variables, not different number of observations across variables. I mean, we present the descriptive statistic for the sample we use in the econometric estimation. So now I would like to write 3 concerns, and after that 3 questions, and that's all. The first concern for me regarding the endogeneity of GDP growth, I mean the economic growth. Usually GDP growth may be itself an endogenous variable and may be influenced by both natural resources rents and also by educational public spending. The same thing for public education spending, which may be also endogenous. For example, in countries with high gender inequality, the government may spend more education spending for this issue. And at the same time, the paper talk about the endogeneity of resources rents, but no discussion about the potential endogeneity of the cost term between natural resource rent and education spending. And so my second concern regards the interpretation of the moderating effect of public education spending. So your reasons indicate that education's expenditure improve gender equality. But we also see that the cost term is positive. That means in country with high natural resources rent, the marginal effect of public spending on gender equality is also higher. I think this point this point deserve a more detailed discussion because it's a good, I think, an interesting result. And the third concern here regarding the threshold analysis in your paper, your findings show that the threshold for tertiary education expenditure is around 35% of GDP, very, very high, really very high, and it is impossible to reach this threshold, given that the highest level of the sample is around 13%, and in many OECD countries, this ratio is around 5%. It's also the same case in France, around 5%. So I think it's not something very realistic. Well, I don't know how to revise this finding. And at the same time, I see that the discussion on page 24, it seems that it doesn't correspond to the table 7 when you report the marginal effect. And so finally, 3 other questions. The first one is like Yasmine, really the heterogeneity of the sample. I think Africa is very heterogeneous. So maybe subsample like West Africa or North Africa should be interesting to do. The second point, the second question here regarding the nature of the resource rent, because in some studies, the authors show that the oil rents may be a key driver to increase the gender inequality. So in your paper, you use the overall rent resource on all kind of resource. So maybe it's interesting to separate different kind of resource in your paper. And finally, the effect on girls' education. Usually we talk about social norm, we talk about effect in the long term, and so how this effect could be observed empirically in your paper, because we focus on the effect of natural resource, but education for girls also is in social norm. It's also very a long effect, long-term effect. Yeah. Thank you so much. That's all.
Thank you. Very constructive remarks. Thank you so much, Kim. We will not have, unfortunately, we will not have enough time to answer all questions, but maybe Idrissa, you would like to address 1-2 comments before we move to the second presentation. You have 1 to 2 minutes maximum. Thank you.
Okay, thank you very much. I would like to thank the discussion for their comments and suggestions, which are really insightful and helpful. So I think there is no much things that I can say about that. What I will say is that I will consider your comments and suggestions to improve my paper and submit it to a journal. So I fully agree with you on the different aspects that you have indicated, and I will look at them carefully and take them into account. But regarding the threshold, I agree with you that 35% is impossible, since the maximum of public expenditure on education in the sample is 13.20%. Okay, but when I look at the countries individually, there are many countries which have reached at least the threshold to reduce gender inequality at least in the secondary level. So the country like Lesotho, Botswana, Mauritius, yeah, and other countries, they have reached at least the public education expenditure level, which can offset the negative effect of resources. But for the tertiary education, it's extremely difficult and even I will not say impossible, but very difficult, because maybe the magnitude of this level is because of the inequality that we have observed between the three levels of education. We have seen that the inequality is massive, particularly at the tertiary level, meaning that the government needs significant resources to close this gap. So okay, maybe it will take time for that. Okay.
Thank you, Idrissa. So let's now move to the second presentation, and thank you all for this very insightful exchange. It's really nice to hear about this topic, and then to have all these comments to contribute to the paper. Thank you. So let's move to Sapan, please. If you can share your screen.
Yeah. Is it visible now?
Yes, and please stick to the time, so maximum 20 minutes, so that we can collect then the different remarks.
Is it now visible? My slides are visible?
Yes, we can see it.
Yes,
thank you.
Yeah. Well, yeah, thank you, Idrissa, for an interesting talk. Yeah, that was really interesting, and a big thank you to DevConnect and the entire team for organizing such events regularly and giving us an opportunity to present our works. So yeah, this is basically the title of my paper, The Womb Under Heat, Temperature Shocks, Maternal Care and Birth Weight in India. This is also one of my PhD essay that I'm currently doing in India, and started with the basic motivation. Like we all must agree to the fact that we all are experiencing a new climate reality in today's world. The kind of extreme heat days that we all are experiencing, the kind of extreme weather that we are experiencing, it gives us a clear indication that we all are living in a new climate age, where the world is set to cross the 1.5 degree threshold or the tipping point. And if we talked about the seasonal anomalies, extreme heat event is now emerging as one of the greatest threat to the humanities, and now it's no longer just a seasonal shock or weather anomalies that only occur during the summertime. Rather, it is with us staying us with a longer duration. When I say this, what I mean you can see this graph. This is the global average temperature, which clearly indicates that over a period of time, particularly from the 2000 and if we say current year, like the last year 2024 and 25, the global average temperature has already crossed 1.5 degree tipping point, which is very dangerous to the humanities. And if we talked about the India, in India case, these are the seasonal anomalies, and these seasons are strictly classified as per the Indian Meteorological Department. As you can clearly see this from the baseline from 1991 to 1910. What we are experiencing in the recent decades, every season on an average 2.5 or 3 degree higher or warmer than they were before. So this clearly indicates that heat events are no longer just an weather anomaly. They are here and impacting our life in every possible way. And unfortunately, the burden of heat is very unequal, and people from lower socioeconomic background, particularly lower income settings, they are the one who bear the burdens particularly. And among those, women are the more vulnerable. Why they are vulnerable? Because of the structural inequalities, restricted gender norms, and uneven power imbalances in the society, which makes them more vulnerable to the extreme heat. Like among the women, it is the pregnant women, those who are bear the double burden of it. Why we call it a double burden? Because in one side, the societal structure, the gender inequality that present in our society, and in the other aspect, the physiological changes that happens during the pregnancy. So this double burdens makes a pregnant women particularly more vulnerable to extreme heat, and they are the one who paying the much higher cost than the other. What exactly does to the pregnant woman? It changes the metabolic demand, it alters the thermoregulations, increase the cardiovascular stress, increase the blood pressure, which complicated the pregnancy duration and complicates the disrupt the fetal development, which may rise the risks of the preterm birth, stillbirth, and low birth weight. If we talked about the global evidence, particularly the evidence now emerging, particularly from the global north and the high developed country, and there are very few articles those who are arguing that how heat is impacting maternal health in the lower income setting, particularly in the context of India. One landmark study has been done by the Banerjee and Maharaj, and this study has been published in the Journal of Development Economics. They are analyzing this, how heat is impacting infant mortality rate in the rural India, particularly, and nonetheless there is a huge evidence gap, particularly in the Indian context, that how in utero exposure to extreme heat affect the early life of the children's health, and we grossly we don't know that how it is impacting to the pregnant women, and that impact can translate it to the children who's not even born. So the main aim of this research is to identify in utero exposure to extreme heat and how it is impacting the children's birth weight in the India by taking a large scale household survey data. So when I say we are assessing the impact of extreme heat on children's birth weight, one question is coming up, that why we are using birth weight, why we are taking birth weight in particular. As you can see, it's a stubborn challenge that has been faced by the India. On an average, 40% of the low birth weight cases are from the developing country, and that is contributed by the India. As per the NFHS DHS5, 18% newborn babies are born with their low birth weight. The earlier studies, particularly taking in the health, socioeconomic, demographic, health infrastructure, and all other factors, those who are related to the linked to the birth weight. But as I said, there is a second to none study. Like there's a very few study in the developing countries, those who are arguing how environmental stress, particularly heat, can impact the birth weight in India. And particularly low birth weight has also a very greater consequences for the children's later life, because it has a very lower IQ, lower productivity. The literature are now coming up in this field also. Yeah. So so the studies try to answer this question. So this is basically just a summary of my research paper, that the question that we are asking, that try to answer, is how parental exposure to extreme temperature affect the birth weight in India. For that, we take two particular source of data. One is the DHS Demographic Health Survey for India, the round 5, and another the temperature data we take from the ERA 5, which is also known as European Research for the Medium Range Research Forecast, which give us the 5th generation temperature data. For the empirical strategy, we use fixed effect regression model, and where we use the temperature beans, and we also use a novel temperature deviation index. The findings are saying that when the temperature cross 32 degree, it on an average reduce the birth weight 0.45 gram, which is in the beans result. In the temperature deviation index, we are analyzing like the highest quintile experience 18 gram less than those in the it's compared to the lower quintile. And one interesting mechanism we found in this study is that how heat, like what factor derives these impacts. And interestingly, we found that when heat is increases, the number of antenatal care get reduced. That the regular checkup that a woman should go, that a pregnant woman should go, that get reduced when heat is increasing. I will discuss more on this. So yeah. As I said, the part of the first study that utilized the national data and map the relationship between extreme heat and birth weight in India. We use also the novel temperature deviation index. And an interesting mechanism we found, that is a behavioral mechanism, that when heat is increases, it impacts the individual behavior. It get like in a daily life. The rising temperature is now also impacting our decision making process. For this, as I said, the data we use demographic health survey 2019-20 for India. The DHS is also provide detailed information about the child and maternal birth history. The DHS is also provide the GPS coordinates for the cluster. What the cluster means a geographical area, particularly a 1 or 2 village in the rural area or a census certified block in the urban area. So DHS provide the GPS location of those clusters, which is help us to assign the temperature. When I see the coordinates, you can see this is the India map, and these are the different clusters that are like the data are collected across India. Then we assign to those clusters the daily average temperature and rainfall data with 0.25 grid latitude and longitude. The method basically we follow that, as I said, we are looking in utero period exposure to the extreme heat. For that, we need to define the pregnancy window. We need to define the pregnancy period, that in which window that women experience the pregnancy. For that, the DHS give us the pregnancy duration. That we track back from the 9 month back from the child of the child date of birth. We back from the day of child born to 9 month back. And that is the pregnancy window that we define, and that is something not done randomly. DHS is also provide the pregnancy duration, which is help us to keep the which is also help us to restrict the birth with reported gestational length like the 9 month only. Like we kept our sample only to 9 months because we define 9 month only to that child date of birth to 9 months. So that also helped by the DHS pregnancy duration. Then we assign temperature data to those cluster by creating buffer zone. And what is the buffer zone? We create a buffer zone and a surrounding area to that cluster, particularly 5 kilometers to, you can see it from here, particularly 5 kilometers in the rural area and 2 kilometers in the urban area. We create this buffer zone. Then we assign that daily average temperature data to that entire 9 month, the pregnancy duration to that woman. Then that 9 month is divided into 8 temperatures, 8 nonlinear temperature beans. That 9 months divided into 8 temperature beans with 4 degree interval. As you can see, it started from less than 8 to greater than 32 degree and with 4 degree interval. And this is something also that not done randomly. This is completely based on the data distribution and the percentile of the temperature data. When I say temperature beans, you can see it here. You can see like it's much more clear. These are the temperature beans. And these are the numbers of days that and on an average an woman, pregnant woman, experience during their pregnancy. And some of these days is equal to pregnancy duration. So as you can see, approximately 32 and 73 days they are experiencing more than 25 degree, which is country's average, more than country's average. So yeah, this is the bean, and these beans are particularly our main explanatory variable. Yeah. So started with the basic empirical model. So our basic empirical model assumed that the birth weight of children's I whose mother lived in the cluster C in district D in the year Y, which is a function of those 8 temperature beans. And we also use the rainfall traceile to control for the rainfall impact on the temperature. There are several other controls we are included like household characteristic and mother characteristics. We use the cluster fixed effect. What does cluster fixed effect do? Like the different cluster may have different socioeconomic factors, different socioeconomic development, so that might impact our result. So to control for that, we use cluster fixed effect. Similarly, for the birth year fixed effect, different year can experience different weather anomalies. To control for that, we use birth year fixed effect. And for the seasonality, we use district birth year fixed effect. What this capture? Actually, when you talked about particularly in the Indian case, many coastal states are experiencing several cyclones during particular period of time, and those cyclones are not impacting to the other landlocked states. So that might have impact to our sample, particularly into those coastal area. To control for that, we use district and birth year fixed effect. There are also another seasonality control we used in our robustness that I will discuss in later. And the identification, obviously, after using the fixed effect, the variation in the temperature during pregnancy possibly exogenous to the unobservable maternal characteristics. So this is basically the identification assumptions. As I said in the earlier, we use also temperature deviation index. Even though the temperature beans giving us a nonlinear impact of temperature on birth weight, still the picture is not clear. Because why I'm saying this? Because 30 degree or 32 degree is not same in every places. If I say in Delhi 32 degree and similar 32 degree is not same in other state of our India. So it's often like we neglect this part of the work, that how we should like control for that long-term adaptation of the people, like people adapt to their local climate. To control for that, we use a temperature deviation index by using exponential function, where we use district session base. We also tried with the cluster, but there is no variation left. The weather variation is no, there is very less variation in the cluster level. That's why we use district session base. And this district session base, what we did, we take the long-term average from 1990 to 2013. Why 2013? Because after 2013, like our data started from 2014, so birth data. So that's why we kept it with the 2013. Then we take that long-term average with each district session base, and the session are particularly strictly divided into 4 categories as per the IMD, as earlier I said. Then we take this long.
Sorry for interrupting you. Sorry for interrupting, but we still have 4 minutes for the presentation, so please try to keep the time up.
Exactly. Sorry.
Cover the results and conclusion.
Exactly. So then we see the impact that by taking the district, like the long-term average, then we subtract the actual temperature what they are experiencing during pregnancy. Then we get the actual value, deviated value, that what exactly whether upper value or the lower value during the pregnancy they are experiencing. This is the result, and the left hand side is the temperature beans result, which is clearly indicating that when temperature cross 32 degree, it's weighs around, or its impact or cost around 0.45 or around 0.5 gram during their pregnancy. Like if a woman experience a additional day temperature above 32 degree, it's cost around 0.45 gram birth weight. If we talked about in the index result, as I said, the lower quintile has the positive value. There is no impact. When the exposure is going like increases, the highest quintile, with the highest quintile, we have on and around 18 to 20 gram less than those as compared to the lower quintile. So the impact is pretty much higher. We also test whether the exposure has a very time specific, and like which time is much more vulnerable to extreme heat. For that, we also test the trimester result, and for that we test like the both temperature beans and deviation are saying the latter part of the pregnancy, like the second and third trimester, are much more vulnerable to the extreme heat. As I said, that heat has a very unequal impact. To test that, we also test the heterogeneous impact by taking rural and urban, and the rural peoples are bearing the much more burden than the urban. We also test the child sex, guys, girls and boys, which is also aligned out with our medical literature. That medical literature is also saying that the boys are much more vulnerable than the girls. It doesn't mean that girls are not vulnerable. They are also vulnerable, but boys are much more vulnerable, which is medical literature is also saying that. If we talked about mother educational level, the less educated mothers are bear the most burden. We also test the regional exposure. How we did it? We did it with the like the IMD classified, Indian Meteorological Department classified different state, like the high heat stress state and the less heat states comparatively. So if you see the result, both the like high heat and less heat states are experiencing, but the high heat states are have a very the magnitude of the impact is very high for the higher like high heat vulnerable states. And these are the heterogeneous impact. So what derive these impacts? What drive these impact? When we say heat is impacting maternal health or birth weight, what exactly the pathway that been explain our result? The most of the literature, primarily from the biological or epidemiological literature, they are saying that we don't need a pathway. Heat can directly impact to the maternal health, to the womb. But as a social scientist, it is not just a clinical or biological issue. It is very much social and economic phenomena. The impact of heat is also saved by who we are, where we are staying. So that's why we test like what could be the behavioral channel or what could be the socioeconomic channel that can explain our result. For this, we test an indirect socioeconomic channel, which is find that when heat is increases, the number of antenatal care get reduced. A pregnant woman that should go for a regular checkup during their pregnancy, that get reduced when heat is increases. we also test the series of robustness to validate our identification. This is the baseline model, and we have also tested with the alternative temperatures like greater than 33. The impact is much more than the 32. We also use cumulative degree day, where we use 32 degree as a threshold. Then you see whether the impact is still valid or not. The results are like still like the result is still significant. Another interesting thing we did in our robustness test is the mother fix effect, because individual mothers' health characteristic may differ, and their heredity and their past health condition may impact. To control for that, what we did, we limit our sample and taking only those mothers who have more than one children. Then we make a panel. Then we apply the mother fix effect. Still, our result survives, and we got the significant results. Another interesting robustness we check is the year quarter fix effect, because even though we use year district fix effect for the seasonality, there are seasonal anomalies still there, which can bias our result. To check this, we use year quarter fix effect. The results still hold good, and still it's give us the significant results. In the lastly, we did a balancing test whether to check our identification, whether any unobservable like any maternal characteristic is also linked to the extreme heat or not, and the coefficients are completely there is no link between mother characteristics and extreme heats, and which is also support our identification strategy. In conclusion, parental exposure to extreme temperature significantly reduced birth weight, highlight the fetal vulnerability. Even the fetal is born, the adverse effects are concentrated toward the latter part of the pregnancy. There is a very hugely unequal impact, and marginalized and less educated mothers are more vulnerable, and a behavioral channel that emerges that it not just impact directly, rather it can impact indirect pathway, which is we find it when heat is increases, the numbers of antenatal care get reduced. Yeah, thank you.
Thank you so much for the clear and interesting presentation. I will move directly, since we have a time constraint, I will move to discussants, but I would like you to summarize your comments in less than 3 minutes. In 2 minutes, the essential points, please share them, and then we will move to the answers briefly with the presenter. Thank you. So we will start with Yasmine, please.
Thank you. So the paper is well written. I cannot negotiate on this. The thing is, I have I did this paper, but on the Middle East, and I know how much work it takes. The thing is, the paper is too long, like ours, and what we did is we started to cut off the paper in order to get it published. So this is one advice. Having just one round of DHS, I feel like it's not gonna be a good idea, because climate change effect is over time. So it's better to add other rounds, and already India has other rounds for the DHS. One advice from our paper is that the wealth index of the household, it was significant. So it was it improves we're working on stunting and wasting and the children mortality. So it decreases the probability of having these issues. The second thing is the temperature anomalies. It should be 30 years. So if you start from 1990, it should end at 2020. This is how it's the standard climatology reference. For the part, you need to clarify that you are using cross-sectional data. It's not written in the paper, and you are using how would you find the panel thing. It's written, but it needs to be highlighted a little bit, or rewrite it so it's clear how did you specify this panel data. My advice is, I was a mother of 2, so one was born in December, and I got all the summer while I was pregnant. It's completely madness. But those who, like my other kid, she was born in September, so I didn't spend that much in the summer. So the timing of the pregnancy with like the time the temperature increases is very important in this matter. The final thing I would advise, in order to get this paper into a top journal, you have to look for a JOC. This is what Eliana has advised me last year. I was in your place, and she said you have to see before and after. So having like a staggered diff and diff will push the paper into another level.
Thank you,
Or
yeah.
the last thing, or like over 24 degrees, greater than 24 degrees, you might do regression discontinuity. That's another option. Thank you so much.
Thank you, Yasmine. Susanta, can you make it in less than 2 minutes? Thank you.
I will just straight away, I will mention 3 points from my side. So my methodological suggestion is that the paper should be more explicit about residual spatial dependence and serial correlation. So that part, because 2 kilometer and 5 kilometer, that is also very huge area of coverage. So nearby districts are likely to experience correlated weather shock. So it would be strengthened if the paper to discuss the clustering level clearly, and if possible, a report across a cross-sectional dependence check. That is my first one. Second point is ANC result is interesting, but I would be cautious as a possible behavioral channel rather than a fully identified mechanism. Because if you look at the at your mechanism, it clearly states that just a minute. Just a minute. Mechanism. Yeah. So extreme heat, it is only related to if level of heat increases, so ANC visit decline. But birth weight is also related to the mother nutritional level, and also during the heat wave, if mother get exposed of any medical shock, so because of the treatment, that may have adverse impact. So how many times a mother got affected during the heat wave, during the pregnancy period, if it is possible to consider, that would be a great contribution. Last point is that recent India evidence support the relevance of heat for healthcare utilization during pregnancy, but it doesn't eliminate the alternative explanations such as income shocks, mobility constraint, or seasonal selection. 3-4 papers are there that I will share it with you. And thank you very much. The idea is very good, and you have tried to incorporate novelty in your research design. So obviously it will take time, but that's fine.
Yeah, thank you.
Thank you. Thank you. And finally, with Kim.
Yeah, thank you so much. Thank you, Mr. Sapan, for your presentation. So first of all, I would like to start by underlining several positive points of your paper. The first, I feel that the paper is follows a very clear and consistent structure. And second point is you combine different data sets, including rainfall, temperature data, and socioeconomic data. Is it really a challenging task? After that, you also you build an asymmetric temperature indicator. It's not easy, and this allows to capture the asymmetric effect of increasing or reducing of temperature. So I think it's very a good point. And so some minor comments before raising 3 concerns or questions. The first one is a very minor comment. In session 4, there are 2 questions labeled number 4. And the constant term in equation 2 is negative, but in equation 4 it's become positive. So just maybe it's a typo, just to check that. The table 6 appears to duplicate information in reported in table 5. I mean, table 6 and 5 are the same, it seems that. Regarding the reference, reference are not ordered by alphabetical order, so you have to check that. And the paper alternate between the use of I and we, so just to harmonize this utilization, that's all. And so here it just 3 main questions and concerns. The first one regard the DICT index. So the parameters K1 and K2, so you adopted them in another paper. I see it is not at all. So they propose a numerical simulation, and it seems that these values are not justified. I mean, biological point of view. It seems that, and it's also a value adopted for simulation, and you use the same thing. So I think I don't know how your reason will change if you adopt an alternative, alternative parameter choices. The second concern here, I think, is the most important one regarding the effect size. So the main reason show that an additional day with temperature about 32 degrees reduce birth weight by 0.45 gram. So if we continue with this argument, a 10% increase of the cumulative DICT index reduce birth weight about 2.2 gram. And this represents only 0.1% of the average weight of the baby. I mean, so so very small. It's really close to 0. And I continue. So given the average,
Kim, I'm so sorry to interrupt you, but to keep us on track and to give the floor to Sapan to answer. If you have one very important question or comment to give him, please go ahead.
My question is regarding this reason, how could we provide and we discuss policy application in the conclusion session? And the last one regarding the survival bias. I mean, your sample, you use only data. You use only data without miscarriage and stillbirth. So maybe you are underestimating the effect of it. I mean,
Thank you, Kim.
That's all. Thank you.
Thank you. Sapan, in 1 minute, and maximum 1 minute, so that we can conclude, please.
Thank you everyone, like particularly our discussants, they provide really insightful comments. Like most of the, like one of the important comment that I found is that how many time mother affected, that is a doable thing, so we can incorporate that things. And the concern that you raised, the impact is very negligible or close to 0. That is, we should not interpret in that way. I would rather say that is an additional day they are experiencing that deviation. So as I say, like so my chart, they are experiencing on an average 32 or 33 days above 32 degree. So if I say, if I cumulatively taking into account all those days, then the impact might have much more than what is currently visible. So we are interpreting in a singular day, like additional day deviating from this index, and the impact is this much. So if we combinedly like estimate the like how many days they are experiencing on an average and what is their cumulative impact, then the impact might have been much larger than that what is appeared. And all other things I will incorporate in the comments, and thank you for that. Thank you very much.
Thank you. Thank you all for your contributions and for the stimulating discussion we had today. The DevConnect co-founders would like to thank you all. Since it's the last webinar for this academic year, we are happy that you were able to join, and we thank all people who were able to join our webinars. We would like to promise you very interesting webinars and workshops for the coming academic year, starting September 2026. And I would like to tell you also that we will be sharing with you by email a questionnaire to collect your feedback, to be able to improve our webinars, our research activities. so that we can contribute, we can meet our mission, our initial mission to contribute to research worldwide and more particularly in developing countries. Thank you so much.
Thank you.
Thank you.
Thank you for organizing this. Yeah, thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Bye. Thank you
Bye
very much.
bye.
Bye.
Thank you.
Bye.
Bye bye.